Good morning, viewers. My name is Anna Humphrey, and boy, do we have a lot to talk about. During our news segment this morning, I would like to talk to you about VFD, how it affects farmers, bacteria, and you. The ADAA, which is the Animal Drug Availability Act, gained a regulatory category in 2015 for certain animal feeds and drugs called the Veterinary Feed Directive, or VFD for short. According to the FDA's rule document posted on the Federal Registry, any animal feed containing VFD drug can only be fed to animals based upon an order, called the Veterinary Feed Directive, issued by a licensed veterinarian in the course of the veterinarian's professional practice. The VFD aims to assist in limiting the overuse of antibiotics on animals. It was put in place for the main purpose of trying to minimize antibiotic resistance in bacteria. This is done by making farmers give VFD antibiotics to animals only with the supervision of a vet and a vet's prescription. The aforementioned FDA rule document states that VFD has caused farmers to be worried that they can't pay for or have access to a vet or VFD drugs. This concern is a small problem compared to the alternative, which is having a ton of antibiotic-resistant bacteria birthed from the overuse of antibiotics. Even if we regulate antibiotics in the US using VFD, humans in other countries, mainly developing countries, are still overusing the drugs for growth and curing unhygienically caused diseases. As seen in the research article, antibiotic use in agriculture and its consequential resistance in environmental sources, potential public health implications, these developing countries are overusing these drugs in their livestock for the purposes of growth and to cure diseases caused by factors including a high prevalence or level of infections, profound scarcity of state management and developmental strategies, shortfall in husbandry zone planning, negligible hygienic practices in livestock husbandry in conjunction with the presence of an integrated agricultural system. The US and other developed countries can't do this by themselves. According to the same paper, the best way to beat this issue is to follow the World Health Organization's Global Action Plan, which demands that each country develops national action plans in line with the key actions of the Global Action Plan to surveil antibiotic overuse and make sure there is no need for said overuse. So now that we know what we are striving for as a solution, let's take a look at how this problem arises in the first place. Let us transition into our next segment, mouth-watering microbes with our chef Matthew. Off to you, Matthew.
Thanks, Anna. Today on Mouth-Watering Microbes, we will be making a honey ham sandwich, which will be delicious. But before we get to cooking, we should know about the potential risks when eating an animal that has taken antibiotics. So, according to a report by the Center for Disease Dynamics, Economics, and Policy, resistant bacteria and antibiotic residuals have been detected in living bovines, chickens, and fish in India, as well as in related food products. As you can tell, consuming these antibiotics-fed animals and their byproducts like milk have shown to not only transfer resistant bacteria and antibiotic residuals, but also cause bacteria to become resistant in the first place. We will go over the specifics of how bacteria reacts to antibiotics in a later segment. This is a large issue because certain animal pathogens are of particular concern because they are easily transferred between species and can cause serious infections in humans. Since the farmers are unknowingly creating antibiotic-resistant bacteria within the animals, they are unknowingly transferring those antibiotic pathogens to humans. It's an even bigger problem since farmers are creating bacteria that are resistant to antibiotics that we can use to cure humans of bacterial infections. The aforementioned report states that 9 of 14 cases of drugs labeled critically important to human health are also commonly used in animals. If these bacteria are resistant to human antibiotics, then by the time those pathogens make it to us through consumption or other ways, I'll explain in a second, we won't have an efficient antibiotics to defend against the bacteria. This is really bad because those antibiotic-resistant bacteria can be deadly. According to the CDC, more than 35,000 people die annually from these bacteria in the US. Now you might be thinking, you could just avoid eating meat or animal byproducts to avoid these bacteria, but the report shows that the bacteria via animal poop can travel into water and soil, making its way into produce. This makes it a problem for anyone who eats. Even if antibiotic-resistant bacteria weren't the issues with putting antibiotics into the feed of animals, there is still the issue of antibiotic residuals that can be consumed in live livestock, and their byproducts. According to an already cited article, antibiotic use in agriculture and its consequential resistance in environmental sources, potential public health implications, the consumption of these meats, milks, and eggs contained with antibiotic residues usually has tremendous impacts on the health of humans. They can be exhibited as drug hypersensitivity reactions, hepotoxicity, aplastic enema, carcinogenic, mutagenic, immunologic, titologic effects, nephropathy, disruption of normal flora of the intestines, a reproductive disorder, as well as development in the antibiotic resistant bacteria in the gut. As you can see, the aftermath of frequently giving animals antibiotic beyond what should be given can result in transferring antibiotic resistant bacteria to humans, which is proving to be more and more dangerous, and can also result in giving humans antibiotic residuals that can be detrimental to someone's health. Now that we have discussed the dangers of giving animals antibiotics, let's make that sandwich. 1 second, I'm receiving a phone call. Yes, hello. Okay. That was my producer. She says that we don't have enough budget to buy the ingredients to make the sandwich this week. In that case, let's head over to our next segment, micro meetings with the microbiologists. Off to you, Sophia.
Thanks, Matthew. Today on the show, we have something special to discuss: how those pesky bacteria react to antibiotics and why we use the drugs in the first place. When an antibiotic is administered, there are 4 ways that bacteria can be neutralized. According to the Milken Institute of Public Health at George Washington University, these 4 ways: 1. Disrupt cell wall synthesis, inhibit RNA synthesis, protein synthesis, and DNA replication. Although these antibiotics are meant to target the bacteria, disrupt, and destroy them, there is still the possibility that they survive. According to the same article from George Washington University, the bacteria can survive the antibiotics by mechanisms of antibiotic resistance. These mechanisms are natural resistance due to an impermeable substance membrane or a lack of a target, modifying the antibiotic target, producing an enzyme that inactivates antibiotics, and pumping antibiotics out. These mutations lead to the bacteria being able to live on and replicate. This also allows for the bacteria to multiply and inherit the antibiotic-resistant mechanism that allowed the bacteria that survived the antibiotics in the first place. The more we use antibiotics and overuse them in animals, the greater likelihood that the bacteria with mutations will survive, replicate, and spread. Next, we have a veterinarian guest in the studio to take my colleague Jake's questions. Over to you, Jake.
All right. Howdy, Dr. Talcott. How are you doing this morning?
I'm great. Thanks. How are you doing?
I'm doing just fine. So I have a couple of antibiotic resistant questions for you. Today we're going to start with how do antibiotics affect an animal's immune system, if they do at all?
Well, it depends on the antibiotic. It doesn't really impact the immune system. What it does is, if an animal has an infectious disease that the animal's immune system is trying to battle or fight off, then if the antibiotic is also helping to get rid of that disease, like E. coli or Salmonella or Campylobacter, that impacts the immune system because it helps the immune system to ward off that infection. So as a direct impact, it really doesn't impact the immune system, but it indirectly impacts the immune system because it helps to get rid of those bacteria.
And then, can animal byproducts such as milk or honey affect the human immune system / the bacteria resistance, or in other words, antibiotic resistant bacteria, if the products have antibiotic residue in them in the honey or milk? And if so, how?
Oh, there's some feedback. The animal byproducts or the animal products, the meat, milk, honey, and honeybees that's another issue that people are looking into now. They can have residual antibiotics in them, or during the processing, if say a slaughterhouse, the antibiotics are in the digestive system or in the feces or the urine, and it contaminates that product. Those are ways that those antibiotic residues and the antibiotics themselves can get into the human population through consumption. So then what happens is if you're eating or drinking those products and there are small amounts of antibiotics still in them, then yes, it gets into the human food chain, which then can impact human health. And again, it's not necessarily the immune system, but the antibiotics themselves can alter your microbiome, the bacteria that we all have in our bodies. And the microbiome is really what people are focusing on now, that impacts a lot of different things. And we're finding out more about how the microbiome affects certain diseases like Alzheimer's and multiple sclerosis and cancers, how certain microbiomes are more prone to developing these diseases. So by changing your microbiome and by these bacteria getting into the food chain can alter the microbiome that can then alter how people develop diseases.
Awesome. And or the VDF, I would like to know, do farmers still overuse antibiotics in their feed in order to promote growth or keep their livestock healthy despite this directive?
Well, it's less. There is still antibiotic use in food production for the purposes of treating animal diseases. So animals get salmonella, they get E. coli diseases. They're not used as growth promoters. So the reason that antibiotics were used in agricultural production was because they allowed animals to grow faster, quicker. And the quicker you can grow an animal, the less expensive it is. So if you are giving these antibiotics that promoted growth, then you were able to produce a product for cheaper and make more money. But again, that was corrected several years ago, and we recognized it wasn't a good idea to put these antibiotics into the food chain. And so now, rather than the farmers being allowed to just use these whenever they wanted to, this has to be done under veterinary directives. So it's a lot harder. And I would say, most people are abiding by that. There are always some people that can not follow the rules and do this not according to what the regulations state. But for the most part, most people, most producers, agricultural producers are following the rules, and we're reducing the amount of antibiotics in the food chain.
Awesome. Well, that's all the time we have today for our segment. Thank you so much, Dr. Talcott, and our viewers will see you again next time.
For our final segment, we will discuss the forecast of antibiotic resistance bacteria. We've already covered the dangers of antibiotic resistance bacteria and how we are trying to combat them by simply administering less antibiotics to animals through the VFD. There is still the issue of restricting antibiotic use in other countries that are out of the United States' control. This has led researchers to try and find other ways to combat antibiotic resistance bacteria. One of the newer developments has been using antibiotic hybrids. In the research article titled Next Generation Strategy for Treating Drug Resistance Bacteria, Antibiotic Hybrids, the researchers discussed that antibiotic hybrids are synthetic constructs of two molecules which are covalently linked. These could be 2 antibiotics or antibiotics with an adjuvant, efflux pump inhibitor, siderophone, etc., which increase the access of the antibiotic to the target. This approach could soon be better than the single or even combination therapy, which is when you use multiple antibiotics to treat something. But combination therapy has shown no benefits during in vivo studies. The antibiotic hybrids are seen to have potential since they can possibly do well against gram-negative bacteria, which are bacteria that have an intrinsic resistance to currently available antibiotics, mainly due to overexpressed efflux pumps, which are constitutively present, and also presence of protective outer membrane. There are trials happening currently, and we will hopefully see soon if this development is as promising as it seems. Until we find out if antibiotic hybrids work well, we as a species need to make sure and limit the overuse of antibiotics on animals, so antibiotic resistance bacteria don't become overwhelming. That's all for today, folks. Thanks for joining us, and stay tuned for more information.